So for section 8.2, part 2, we're going to look at rational exponents and how to take these rational exponents and apply them as radicals in simplification problems. So the first thing that I actually want to look at is some similarities and differences between these three problems. I really want to make sure that we're aware of how to handle all these negatives we are about to be thrown. So I'm going to start right here with this first problem right here. So I want you to take careful note that the negative is not actually being raised to the 1/4, the 16 is. So when this happens, we're actually going to set this negative aside, complete this part of the problem first, and then attach the negative. If this was in parentheses, if the negative 16 was in parentheses, then the negative and the 1/4 would go under the square root if both of them were in parentheses. They're not, so the negative 16 we just kind of have to set aside. So that negative gets set aside, like I said before, and you would actually convert this to the 4th root of 16, which is what we just worked on last section, and the 4th root of 16 is 2, and then you would attach that negative, giving you an answer of -2. Now let's look over here at this second problem. The 16 is actually not negative, but the exponent is. So remember, when we have negative exponents, first thing we have to do is make them positive. We can't do anything with negative exponents. And the way that we make negative exponents positive is we actually put them into the bottom of a fraction, or the denominator of a fraction. So this would be 1/16 to the positive 1/4. Now that we've got it as a positive exponent, I can convert it to 1 over the 4th root of 16, or 1/2. This is a completely different answer than the first column. And now let's look at our third column. We actually have two negatives here. We've got a negative in the exponent and a negative on the outside. Now remember, we need to set this negative out here on the outside to the side, and as we do that, I'm actually going to make that exponent a positive 1/4 by moving it to the bottom, giving us -1 over the 4th root of 16, or -1/2 as our final answer. As you can see, three completely different answers by similar problems. So you just want to take your time, make sure you're really careful, and pay attention to where those negatives are. All right, I want to take a minute and look at a problem with some rational exponents. Let's take x to the 4th, y to the -6th, over x to the -2, y to the 1/3. And all of that is going to be raised to -2/3. Now you know the first step. The first step is going to be to take whatever exponent is out here and to distribute it in. And you're actually going to have to distribute it into all four of those pieces. And when we distribute it in, we multiply. So I want you guys to look at this like this is 4 over 1, and -6 over 1, and -2 over 1. Like they're all fractions or rationals, because that's going to enable you to multiply this just a little bit more simply. Because remember, when we multiply fractions, we do numerator times numerator. In other words, -2 times +4, and then denominator times denominator, or 3 times 1. So in this case, we would actually have x, and then that would be to the -8/3, y to the +12/3. Notice I'm not simplifying anything yet. I'm keeping it straight here. Then I jump into the bottom, and that would be x to the +4/3, y to the -2/9. So once I have that distributed in, if you remember from a couple units ago, the next step is to take these negative exponents and make them positive. So for my next step, I'm going to take those and flip them. So that y to the -2/9 becomes y to the +2/9 in the top, with y to the -2/3. The x's come down. That x to the 4/3 stays. It was fine where it was at. And then that x to the 8/3, or -8/3, becomes x to the +8/3 when we move it down. Our next step is to put these together, to put y's with y's and to put x's with x's, but you'll notice when we do this, we add exponents. So what I've really got here is I've got y to the 2/9 plus the 12/3. And on the bottom, I've actually got x to the 4/3 plus 8/3 because we add those exponents. Well, the problem is these are fractions, so we have to have common denominators. So for example, up here when I'm looking at my y's, I'm actually going to have to multiply the top and bottom by a 3, getting me 36/9, just so I can have a common denominator and even put those together in the first place. What that's going to do is that's going to get me y to the 38/9 on the top, and then it's going to get me x to the 12/3 on the bottom. Remember, 8 plus 4 is 12 divided by 3, and 12/3 actually could just reduce to x to the 4th. As long as your x's are with x's and y's are with y's and you have no negative exponents, this is your solution. So I want to take a look at a similar problem. This actually is m to the 3/4 times a quantity. And what we're going to need to do is take that m to the 3/4 and actually distribute it in. When we do that, we're multiplying. That's m to the 3/4 times m to the 5/4. And remember, when we multiply like bases, we actually add those exponents. So for that first term, m to the 3/4 plus 5/4, we actually end up with m to the 8/4 or m squared. Now I got to do it again. I got to multiply it times this second guy. So minus, remember once again, when we multiply we add exponents, so that becomes 3/4 plus 1/4, in other words 4/4, or m to the 1. So what we really have is m squared minus m to the 1. Now at this point I can't put them together. When we add and subtract, we only put like terms together. We're subtracting here and these aren't like terms, so I've got to stop. Now for this last problem that we're going to look at, I'm going to look at it in radical form first. I could use my Algebra 1 rules and rationalize this denominator, but it would be pretty nasty. And I'm going to teach you that here in a few sections, so you'll have another way to do this. So I'm looking at this going, how the heck am I going to put this together? Well, I might be able to convert it. This actually is the square root of x cubed. Well, can't I actually write that as x to the 3/2? Yeah, I can if I convert it back and forth. And if I look at the bottom, can't I actually convert that to x to the 2/3? Now, where did that come from? Remember, the index becomes your denominator. Index, denominator, exponent, numerator, exponent, numerator. Now, can I put these together? Well, yeah, actually, since they're both x's, I can. And the way that we put them together, remember, when we're dividing, is we actually subtract. So it becomes x to the 3/2 minus 2/3. Now we need to get a common denominator, so it's going to be a 6. So I'm going to have to multiply these by 2, and I'm going to have to multiply these by 3 to get a common denominator of 6. So I'm going to get 9/6 minus 4/6. In other words, x to the 5/6 would be my final answer. Now, since my original problem was given to me in a root, my answer needs to be given to me in a root. So this, I would need to convert it back to the 6th root of x to the 5th. If you think of our previous problems, they were given to us with a rational exponent. We answer them with a rational exponent. This is given to us in a root. We answer it in a root. And that's how you kind of tell what your answers should look like.